friends, today we solve some examples of maxima and minima. So let us take some examples. The local maximum value. So the local maximum value of fx equal to x plus 1 over x is blank. So options are 2, -2, 4, -4. Now see here we are having fx is x plus 1 over x and its derivative is 1 minus 1 over x square. Now for critical points we take f dash x equal to 0. So 1 minus 1 upon x square is 0, and this would imply x square equal to 1, and so x equal to plus minus 1. And we take the second derivative also, that's easy here. So second derivative is 1 over x square derivative is minus 2 over x cube. So minus sign is already there, so that is 2 over x cube. And we want maximum value. So we know that if the second derivative at the point negative, then we get f is local maximum at x equal to a. Okay, so we are having 1 and minus 1, so we easily find that f second derivative at minus 1 is 2 over minus 1 cube, so that is minus 2, and which is less than 0. So therefore at x equal to minus 1, f has local maximum, and we want local maximum value. So therefore local maximum value is f of minus 1, and fx is x plus 1 over x. So f of minus 1 is minus 1 plus 1 over minus 1, and so that is equal to minus 2. So minus 2 is the local maximum value. Okay, see here the graph of this function is like this. Say the graph here is in this way. And similarly like this. Okay, so here we are getting the local maximum value. Okay, let us take the next example. So here the option is B. The local minimum value of x over log x is blank. So options are minus 1, 0, 1 over e and e. So here we are having fx is x over log x. Now take the first derivative. So we have to apply the quotient rule. So log x square, then log x as it is, derivative of x is 1, minus x as it is, derivative of log x is 1 over x. So we are having log x minus 1 over log x square. This is our first derivative. Now first derivative 0 will imply log x minus 1 is 0, that means log x is 1 and log is base e, so x equal to e power 1 and so equal to e. Now we don't take the second derivative, but we try for the first derivative test. Okay, so let us take the value near to e. So when x is less than e, that means log x less than log e. Log is an increasing function, log e is 1, so log x minus 1 is less than 0. And see, this part is always greater than 0, so that means f dash x less than 0 when x is less than e, and when x is greater than e, we can easily see that f dash x greater than 0. So we are having like this. So here the derivative is less than 0, and then say suppose this is e, so we are having sag here, so that means local minimum. So therefore f is local minimum at x equal to e, and we want local minimum value. So therefore local minimum value is f of e, and that is e over log e. Log e is 1, so that means e. So this D option is the answer. Okay. Next let us take the local minimum value of f(x) is equal to x square plus 4x plus 5 is blank. So here options are 2, 4, 1, minus 1. So see, here we can use the derivative test and everything, but let us try this way. Can we write f(x) as x plus 2 square and plus 1? Now this is always greater than or equal to 0. So we are having this f(x) is always greater than or equal to 1. So that means f has minimum value 1. We can have for x equal to say minus 2. f(x) is 1. So f attain that 1 value also. So the local minimum value is 1. Very quickly you can find out without any calculation. Let us take one more. The maximum value of fx equal to pi cosine x plus 12 sin x is blank. The options are 13, 12, pi, 17. Now here also we don't do anything, we are using one simple result that a cosine x plus b sin x. So this function is having its range is minus root a square plus b square to root a square plus b square. So for our case, this fx is always belongs to minus root of 25 plus 144 to root of 25 plus 144, that means minus 13. So the maximum value we are getting is 13. So here also you don't need to do anything, just use this result and find out its maximum value. Let us take one more. Fx is equal to x log x has local minimum value blank. Options are 1, 0, e minus 1 over e. Now here x is a positive real number. Now fx is x log x. So let us take f plus x. So f plus x is what? So x 1 over x plus log x into 1. So that is 1 plus log x. And f second derivative is easy, so we can use directly f second derivative, that is 1 over x. Now f plus x is 0 will imply 1 plus log x 0, that means log x minus 1, that means x e power minus 1, so it is 1 over e, and f second derivative 1 over e is 1 over e, and so that is positive, and therefore f has local minimum because second derivative is positive at x equal to 1 over e. We want local minimum value, so therefore local minimum value is f of 1 over e, and that is nothing but 1 over e log of 1 over e, and so this is 1 over e, and this is the log 1 minus log e. So this is log 1 is 0, log e is 1, so this is minus 1 over e. So answer is B, minus 1 over e. Okay. Take one more. Fx equal to root 3 cosine x plus sin x, and x is in 0 to pi by 2 is maximum for x equal to blank. So that is options are pi by 6, pi by 3, pi by 2 and 0. Now here we need to take the derivative and then we need to find the things. Root 3 cosine x plus sin x. So its derivative is minus root 3 sin x plus cosine x, and you need to take the first derivative 0. So minus root 3 sin x plus cosine x 0, and so tan x is 1 over root 3, and therefore x is equal to pi by 6. That is already there in the interval 0 to pi by 2. And what is second derivative? So second derivative is from here minus root 3 cosine x minus sin x, and since pi by 6 is in the first quadrant, so sine and cosine is positive. So f second derivative at pi by 6 is negative, because this value positive, this value positive, and we are having sign negative. Okay, so it is like this, minus of root 3 cosine x plus sin x, and therefore f has local maximum at x equal to pi by 6. So the answer is pi by 6. Okay, so now we take the next example. The local minimum value of x square plus 16 by x is blank. Options are 12, 22, minus 12, 2. Now fx is x square plus 16 by x. So its first derivative is 2x minus 16 over x square. Now f dash x is 0, meaning 2x minus 16 over x square is 0, and so x cube is 8, and that implies x is equal to 2. Now we take the second derivative. So it is 2, 1 over x square derivative is minus 2 over x cube, so plus 32 over x cube, and therefore f second derivative at 2 is positive, and therefore f is local minimum at x equal to 2, local minimum value is f of 2, and so it is 2 square plus 16 by 2, so it is 4 plus 8, and so that is nothing but 12. So option A is the answer. Okay, let us take the next example. The minimum value of sec x, where x belongs to 2 pi by 3 to pi is blank. Options are 1, -2, 2 and pi. So let us have the solution. It's not difficult. Fx is sec x and we are given x in the interval 2 pi by 3 to pi. Now f dash x is sec x into tan x. Okay. Now see, we are having the interval is 2 pi by 3 to pi. That means this is in the second quadrant. In second quadrant, both sec negative, tan also negative. So this f dash x is positive. That means f is increasing in 2 pi by 3 to pi. And if the function is increasing, then we will get its minimum value at the lower end. So therefore, f has minimum value at 2 pi by 3. We want minimum value. So the minimum value is f of 2 pi by 3. So that is sec 2 pi by 3. And sec 2 pi by 3 is sec pi minus pi by 3 minus sec pi by 3 minus 1 over 1 by 2, because sec is 1 over cosine, so it is minus 2. So answer is minus 2. Option B is there. Take one more similar example. Let us take one more. The maximum value of cosec x, where x belongs to pi by 6 to pi by 3, is blank. Options are 2, 2 by root 3, pi by 6 and pi by 3. Now f(x) is equal to cosec x. So f dash x is minus cosec x into cot x, and x is in the interval pi by 6 to pi by 3. That means it is the first quadrant. Okay. And so cosec x cot x positive, and because of this negative sign, this is less than 0. That means f is decreasing. F is decreasing in pi by 6 to pi by 3. Now if the function is decreasing, we will get the maximum value at the lower point if the function is decreasing. Okay. So maximum value of f at x equal to pi by 6, and maximum value is f of pi by 6 cosec pi by 6, and so that is nothing but 2. So here the option is A. Okay. Next let us see maximum value of fx equal to cosine of x e to the power modulus x plus 7x square minus 3x, and x is in the interval minus 1 to infinity, is blank. Options are minus 1, 0, 1, none of these. Okay, so now see, in this case we know that for any x belongs to R, cosine x lying in the interval minus 1 to 1. Okay, so this is a cosine function, and for x equal to 0 we get 1. That means that the maximum value of cosine is 1. So for any x, this f is also has the maximum value 1. So the maximum value is here now 1. So we don't do anything, and we can easily find out, because for x equal to 0, this function f is having the value 1. Now because of this cosine, we can't get any value greater than 1. So 1 is our maximum value, and it attained at x equal to 0. Okay, so let us take the next one. The question is the number of critical points of fx equal to modulus of x minus 1 over x square is blank. So how many critical points are there? That is the question. So 1, 2, 3 or 4. Now what is the meaning of critical points? So critical points means the points where f is not differentiable or x such that f dash x 0. So critical points are the points where its first derivative is 0, or the points where the function is not differentiable. Now what is fx here? So fx is like this. It is x minus 1 over x square when x is greater than or equal to 1, and 1 minus x over x square when x is less than 1. Or you can say like this, it is 1 by x minus 1 by x square when x is greater than or equal to 1, and when x is less than 1, so it is 1 by x square minus 1 over x. Now here very clearly see that the function is not differentiable at x equal to 0, and because of this modulus function is not differentiable at x equal to 1 also. So f is not differentiable at x equal to 0 and x equal to 1 also. Okay. Now let us see the first derivative where it becomes 0. So f dash x, So f dash x here we can find it is minus 1 over x square plus 2 by x cube when x is greater than or equal to 1, and minus 2 by x cube and plus 1 over x square when x is less than 1. Okay, or you can have this as minus x plus 2 by x cube when x greater than 1, and this is x minus 2 over x cube when x is less than 1. That means f dash x equal to 0 at x equal to 2. So now we are having total 2 points function is not differentiable. At 1 point its first derivative 0. So therefore total 3 critical points. Zero, 1 and 2. So answer is 3 here. Okay. So let us now take some other example. If f(x) equal to x square e power minus 2x, x is positive, then maximum value of f(x) is blank. Options are 1 by e, 1 over 2e, 1 over e square, and none of these. Okay. Now f(x) equal to x square e power minus 2x. So let us take its derivative. So f dash x, so that is so derivative of x square is 2x, keep e power minus 2x as it is, then plus x square, derivative of e power minus 2x is e power minus 2x into minus 2. So we can take 2, then x, then e power minus 2x outside. This is 1 minus x. Now f dash x is 0 will imply x 0 due to this, or x 1 because e power minus 2x never be 0. So there are 2 points we are having, x 0 and x is 1, and we want even we are having x here greater than 0 and we want maximum value. Maximum value means the second derivative should be less than 0, or another way also we can take if we don't take the second derivative. So let us first try for x equal to 1. So let us take when x is slightly greater than 1. So at that x is greater than 1. So x minus 1 greater than 0, and 1 minus x less than 0. So this is less than 0. These all are positive because x is greater than 1. So f dash x less than 0. And for x is less than 1, f dash x greater than 0. So we are having the situation like this, negative to positive, like this at 1. At 1, the left side it's no sorry. At 1 we are having like this, So when less than 1, then the slope of tangent is positive. When it's greater than 1, then the slope of tangent is negative. So when the slope is from positive to negative, we get the peak here. That means f is maximum at x equal to 1. So therefore f has local maximum at x equal to 1, but we want maximum value. So therefore maximum value, local maximum value is f of 1, and f of 1 is 1 square e power minus 2 into 1, and so that is nothing but 1 upon e square. So answer is C, 1 upon e square. Okay, let us take one more example. If fx is equal to x square minus 1 over x square plus 1, x belongs to R, then minimum value of f is, option is, does not exist. Because f is unbounded. Second is not attained, even though f is bounded. Third is equal to 1, and fourth option is equal to minus 1. Now see, let us first quickly find f dash x. So fx is x square minus 1 over x square plus 1, and f dash x, again quotient rule, x square plus 1 squared, x square plus 1 as it is, derivative of x square minus 1 is 2x, then minus x square minus 1 as it is, and derivative of x square plus 1 is 2x. And if we simplify this, then we will get 4x over x square plus 1 square. Now f dash x equal to 0 will imply x equal to 0. Now see, this part is always greater than 0. Okay, so we can have this part is always greater than 0. So the part is only need to check about the x on. So when x is less than 0, f dash x negative. If x is greater than 0, f dash x positive. That means the moment of f dash x is from negative to positive. So it is like this, from negative to positive at 0, in the neighborhood of 0. That means we are getting minimum value at x equal to 0. So therefore f has local minimum at x equal to 0, and therefore minimum value is f of 0, and that is easy to see here, minus 1. So answer is minimum value is minus 1. So option D is there. Thank you.